import the dependencies. What I'm doing, I'm pre-processing. What I'm extracting from pre-processing is standard scalar, because this kind of data set will be hugely imbalanced. What I'll be showing you as well, the why the data set is hugely imbalanced and why we need to balance the data set prior to feeding to the machine learning algorithm. Okay, because in case of KNN, in case of KNN is k nearest neighbor, in case of support vector machine, I'll be using support vector machine here as well. So these kind of algorithms do require the data set to be balanced. What I'm trying to say, I'll just explain to you as well. So we have just quickly go overview with the model selection as well. Train test split will be there, SVM will be there, and for the metrics I'll be introducing the accuracy score. So we have done that with our part. We have inputted our data set as well. Now good to go. We have our data frame. So what is period or read underscore CSV? I just go put a question mark here, and on this you can find out the help section which displays what read underscore CSV is all about, what kind of parameters it requires. You can just read it from there as well. I put it in for your reference. So find out the first 5 rows, the shape of it, right? And the AI of the my this Gemini is also there. So it will show that you can generate the code with diabetes data set. It will generate the code you as well. You can also input, you can generate a new interactive sheet as well. You can do that as well. The recommended plots also. It will do that. The AI is also supporting you. So my data set shape is, there are 768 rows and 9 columns are there. So this is a very limited data set. You can find out there are multiple types of data sets in case of the same disease predictions as well. You have pregnancy score, you have glucose score, the blood pressure, the skin thickness, the insulin, the BMI, the diabetes pedigree function is there, the age, and the outcome is there. Okay, the outcome is 1 or 0. We'll see that what 1 or 0 means by it. So we'll move over to our diabetes description that describe the data set. You can see the count of these and the mean is there around 3.84 and the 50% around this. So data set is balanced in case of some of the columns as well, some of the attributes. But if we look at our glucose levels, in case of this is the difference between the mean and the median. And after that, you can see, to move over to the diabetes pedigree function, you can see that 0.47 is the mean and we have 0.37. So 0.10 difference is there. It's not huge, but it is somewhat significant as well. I'll show you what I mean by it as well. So let's find out what are the value counts of it. So non-diabetic patients are 0 and 1 means the diabetic. So 500 patients are non-diabetic and only 268 out of these 768 people are diabetic. And now I group by using the mean values. I guess bring out the means of this. So you can see that the diabetic patients have more values towards the higher side than the pregnancies, than the non-diabetic people who are having the similar attribute values. You can see that as well. And the average age was also a little bit higher as compared to the non-diabetic people. So just I have to separate the data and the labels, because we need to require what labels of what the target should be there and what data should be there to find out if I want to check that whether the desired output is come towards my predicted value as well. So we have to check it as well. So first I need to drop out the column outcome, axis equals to 1 should be there, and then this X will be my data now and the Y will be the labels. So I just print it. Now I print my X as well as Y. You can see that if you can just go through it, the pregnancy's value is there, somewhat 10 is there, some 6 is there, because the glucose 148 is there, 183 is there, 122, some values are nearby, but many values are greatly displaced as well. So my data is dispersed. So in case of pedigree function as well, some of the data, so we need to standardize the data. If you can just look at, I just told you, we need to standardize the data. You can see the Y column is there, that is the outcome part. So for data standardization, we need our standard scalar function. So first we'll call out our scalar, then we'll fit our X, only the data part, not the target or the labels part. We'll be focused on the data part only, that is the X part. I'll just execute it. I'll execute it, and then I've executed it. Now I'll transform, and I'll now print my standardized data. So you can see that the values are somewhat similar now. Now my data is now, the data set is now standardized. So after the standardized data, we again give it to our X. The X, I'll put into X is there. Please have this standardized data instead of the previous imbalanced data. So we have provided that as well. Again, we print those again for the clarity, so that we have done our part correctly.